We are now into Unit 2. So Chapter 1 was just all that beginning stuff that we need to know for math calculations for the most part. So now we are into Unit 2, which is atoms, molecules, and ions. Okay, still a pretty straightforward chapter for the most part. We're just going to be talking about average atomic mass, protons, neutrons, electrons. We'll be doing a little bit of mass percent, and we'll be doing some naming as well. So atoms, what are they, right? Atoms are elements on our periodic table. All those elements over there are atoms, and they are the building block of everything. All right, you are made of a bunch of atoms. There are 3 parts of the atom. Think to yourself, what are these 3 parts? I know you know them. They are the proton, which remember is positive and is symbolized by P+. We got a neutron, which is neutral and is symbolized by N to the 0. And then we got electron, which is symbolized by E to the negative, and it has a -1 charge. Okay, so remember we're going to have to be able to determine protons, neutrons, and electrons of an element. How do we determine protons? Okay, it is the number on the periodic table. It's the atomic number. It's the one right above it. So if I was to look at something like hydrogen, I go look at the periodic table and look at the number above it, and I realize it has 1 proton. Okay, it's got an atomic number of 1. I might look at something like aluminum. I go over to the periodic table, I look right above it, and it's got an atomic number of 13, so it's got 13 protons. Same dealio with copper. I look at copper, I look at the number above it, and I get something like 29 protons. Okay, so got to be able to know how to do that. Pretty basic stuff. Now let's figure out how we can figure out those neutrons and electrons as well. So we're going to be having some symbols that will help us determine that. Okay, you might see something like copper 12 or carbon 12, or you might see something like carbon-12. Okay, these numbers right here are the mass number. So that's a mass number, that's a mass number. It's the same thing, they're just written different ways. Okay, and remember, mass number is protons plus neutrons. Okay, so we could get protons from the periodic table, and then neutrons we could figure out by taking mass number minus protons equals neutrons. So carbon, right, its mass number is 12. I go to the periodic table, I see that carbon has 6 protons. So what must that neutron be in order to complete this formula and make it true? Well, the neutrons must equal 6. Okay, I might have something like carbon 13. Okay, think, what is it called when we have atoms with the same amount of protons but different neutrons? What are those called? Isotopes. Okay, so in this situation, still carbon, it's just an isotope of it because it's got a different amount of neutrons. Mass number, still 13. It's still carbon, or it's not still 13, it's 13. It's still carbon, so still has the same number of protons, which is 6. But now the neutrons are different, right? What is that neutron going to have to equal? In order to make this true, it's going to have to be 7. Okay? So that is just the basics of proton-neutron discovery. But now let's think about electrons. Let me make a little table for us here. Or let's just do an example real quick. Let's say I have something like aluminum 3+, and I want protons, neutrons, and electrons. And I will give it a mass number of, let's say, 27. Okay? So remember, this is the mass number, and this is the charge. The charge tells us how many electrons we're going to have. okay? Well, let's go through this, okay? Protons for aluminum. Again, we get that from the periodic table. We look at the number above it. It is going to be 13, okay? Neutrons, remember your protons plus your neutrons is going to equal that mass number of 27. So protons plus neutrons has to equal 27. So neutrons must have to equal 14. So 13 plus 14 equals 27. We're good to go. Electrons, right? Protons is never going to change. Okay, if I change protons, I no longer have aluminum anymore. I'm going to have something different, like silicon, or I might have magnesium, okay? I can't change the protons. The electrons is what changes. Those go away, or we add extra electrons. So in order for me to have a 3 plus charge, I have 13 protons. So right now I have a 13 plus charge, okay? Electrons have a -1 charge, so what I'm going to have to do is I'm going to have to add 10 electrons in order to get a 3 plus charge, right? If I add 10 negative electrons, what I'm left with is 3 plus. 10 of those electrons cancel out 10 of those protons. After that, I'm only left with 3 protons, giving me a +3 charge. Let's do one more. Oxygen 2 minus 16, okay? So, protons of oxygen, I look at the periodic table, 8. Mass number is 16. If I want to find neutrons, my neutrons plus my protons have to equal 16. Well, 8 plus 8 equals 16. And here, I have a 2 negative charge, so that means I have more electrons than protons. I have 8 protons, that's got to stay the same. So in order to have a 2 minus charge, that means I have 2 more electrons. So that means I have 10 electrons here, okay? So 2 more electrons than those 8 protons, right? 8 protons, 10 electrons will give me a 2 minus charge in the end, okay? So those are the basics of that. Let me give you a table to solve on your own. Protons, neutrons, and electrons. And here is the mass number, okay? We have oxygen. We have something you're not going to know, and we have something you're not going to know. We have 10. That's all we're going to have. Let's go with 8 there. Let's go with 33, 42, 33, and let's go with 15 and 15. Okay, so now we're just filling in the blank. If you want to pause the video here, you're more than welcome to. But I'm going to get going, okay? So I have this oxygen here, and I need to fill in mass number, protons, and mass number once again. Well, I look at oxygen on the periodic table, and it's got a mass number, or an atomic number of 8, so it must have 8 protons. Well, mass number is just protons plus neutrons, so it's going to have a mass number of 18. Here, I don't even have the element, but luckily I have the protons, which will tell me the element. 33 protons, I look at the periodic table, look at which one has 33 protons, and that's going to be arsenic. Okay, mass number, protons plus neutrons, which is going to be 75 for both of these. Okay. And then the last one, again, same deal. We don't have the element, but we do have the protons. And which element has 15 protons? That's going to be phosphorus. Okay, and then neutrons, that's the tricky one. Mass number is 31, right? But neutrons is the tricky one. Remember, protons plus neutrons has to equal that mass number of 31. So what could I add to 15 to get to 31? 16. All right. So that is that. A couple things we got to talk about. Definition or two. Back from our chemistry days. Okay, we have extensive property. I could spell extensive property. Okay, extensive property is a characteristic dependent on mass. So this is if I have a bunch of the same atoms, say I have a bunch of aluminum atoms, and I keep adding aluminum atoms, what characteristics are those going to change? Those are extensive properties, extensive characteristics. Okay, things like if I add more atoms, it'll affect the mass. Okay, if I add more of the same atoms, it'll affect the length. If I add more of the same atoms, it'll affect the volume. Okay, so those are extensive properties, characteristics that are dependent on mass, that change based on mass. Another one that you might remember is intensive property, which is just the opposite. It is a characteristic not dependent on mass. Okay, and how I remember this, you might remember it's got not, right? And an intensive has an N and a T, just like not. So intensive, a characteristic not dependent on mass. So if I keep adding atoms, it doesn't change this type of characteristic. So an example of this is color. Okay, if I keep adding a bunch of aluminum atoms to a bunch more aluminum atoms, it's not going to change the color. Okay, same thing is density. Okay, density is weird because you're thinking, wait, you're adding atoms, so wouldn't that increase the mass? Yes, but it also increases the volume by the same factor. So I'm adding mass and I'm adding volume, keeping the density the same, right? Density is mass over volume. I'm adding mass, but I'm also adding that same amount of volume. Another thing I'd like for you to remember are the diatomic molecules. Okay, whenever I'm talking about oxygen, hydrogen, fluorine, it's going to be H2O2F2. Okay, and remember, I have a nice mnemonic device to remember this. H2N2, F2, O2, I2, Cl2, Br2, right? It's have no fear of ice cold beer. So these are our molecules that are always paired with one of themselves. Hydrogen you never see alone in nature. Nitrogen you never see alone in nature. Okay. The only confusion with this saying is with Cl and Br. Okay. Have no fear of ice cold beer. Don't get Cl mixed up with carbon. Don't get bromine mixed up with boron. Okay. Cl and Br. Cl, Cl, Br, Br. Okay. Next up. Molar mass. We should have this down, but I am going to do just a couple examples, right? Molar mass is grams per mole. It's how many grams you would get if you had a mole's worth of a certain atom, which is 6.022 times 10 to the 23rd atoms. So let's do CaOH, right? What we do is I break it down into its individual atoms, which are calcium, oxygen, and hydrogen. Hold on a second. Let's make the CaOH2. Let's make it neutral. Let's make it a proper compound, okay? So I have one calcium. Remember, if it's in parentheses, that means I have two OHs. So that means I have two O's, and I have two H's. And now what I do is I look at the periodic table, and I look at the number below the element now. The number below the element is the molar mass or the atomic mass. Not the atomic number, the atomic mass. So it's how much one atom weighs if we had a whole mole's worth of it. Okay? So for calcium, I believe it's 40 grams per mole. For oxygens, those are 16. And for hydrogens, their molar masses are 1. Again, I'm getting these numbers by looking below them, and I'm just rounding. I think oxygen is 15.99. I just rounded up to 16. Okay? And then you just add these guys all up. 40 plus 16 plus 16 plus 1 plus 1. I believe that's 72, 74. So the molar mass of calcium hydroxide is 74. Okay? So make sure that you're understanding how to do those. Try it with H2SO4 and try it with, let's go, Al2SO4 3. And in a second here, pause the video, and then here in a second you'll see the work show up on the screen. This last thing I want to talk about is just the classification of elements and their charges. Okay, so these guys over here are alkali metals. Okay, and they all have a +1 charge. Okay, you need to know they have a +1 charge when we start combining them here in a couple days. These guys are the alkaline earth metals. They all have a +2 charge. Okay, this rectangle in the middle stops right here. Okay, this rectangle in the middle are transition metals. They can have varying charges. That's when we use the Roman numerals. These guys all have a +3 charge. There's no name for them. These guys all have a +4 or a -4 charge. These guys have a -3 charge. These guys have a -2 charge. And they are the chalcogens like oxygen, sulfur, and selenium. These are the halogens. They all have a -1 charge like fluorine, chlorine, and bromine. And then the guys on the far right are your noble gases. They don't react with anybody. They have a molar mass of, or not a molar mass, they have a charge of 0, okay? One last thing, let's talk about the transition, or the valence electrons, okay? Valence electrons is just what column it's in. So if it's in the first column, it's got 1 valence electron. Remember, those are the electrons on the outer part of the atom. Those are the ones that react with other atoms. So at the very edge of the atom in its last shell, this one has 1 valence electron. These ones have 2 because it's in the second column. And then we skip all these transition metals, and in this third column there's 3, fourth column there's 4, 5th, 6th, 7th, and 8th. Again, those are valence electrons. Those are the ones on the outside that do not, or that react with everything. They're on the outer shell. Okay. And last but not least, one more thing. See the stair step here? Okay. Remember, everything on the left side of the stair step is a metal. Everything on the right side of the stair step is a non-metal, guys. All right, have a great day.